Hello again. Now we have yet another way to prove that triangles are congruent. This is called angle side. So if two angles and a non-included side of one triangle are congruent to the two angles and a non-included side of another, then the triangles are congruent. Basically goes like this. If angle A is congruent with angle D and angle B is congruent with angle E, and if BC, the side BC, is congruent with the side EF, this is enough justification to show that triangle ABC is congruent with triangle DEF. This is actually just a consequence of the angle side angle theorem, and I'll leave that to you as a little thought experiment. But let's see what some of these proofs look like. And now we have to fill out both statements and reasons. Wow. So statement number one should be whatever my given is. All right, we have the fact that YZ bisects angle WYX. That's a given. We also have the fact that angle YWZ is congruent with angle YXZ. That's also given. So let's write down those facts. Angle YWZ, this is this angle right here, is congruent with YXZ here. And here's a little trick. The last thing we're going to state is what we're trying to prove. That triangle WYZ is congruent with triangle XYZ. That's always going to be the last statement. So now what can I do? Well, let's use the other given that I haven't, like I've already checked this one off. We already used that one, right? So let's use the other one. The fact that YZ bisects the angle WYX. Now WYX is right here, and if YZ is bisecting it, it's going to split it into two pieces like that. So we can establish the fact that angle WYZ is congruent with angle XYZ because of the definition of bisector. Angle bisector. And then we have that wonderful property that we always like to use where the two sides are the same, so YZ is congruent to YZ. That being the reflexive property. Right there. So we note that we have an angle, another pair of angles, and a pair of sides that are congruent. Hence, we have angle, angle, side. Angle, angle, just count out angle, angle, then we hit the side. So it's angle, angle, side congruence. And that's it. Now let's look at one more. So, given the fact that angle ABC is congruent with angle CED, that's a given. And given that AB is parallel with CE, that's another given. We are also given that C is the midpoint of AD. It's another given. What we want to prove, that last statement, prove that triangle ABC is congruent with triangle CED. D. Alright, so let's write out what we know. Triangle ABC, or angle ABC, sorry. Angle ABC, this one right here, is the same as angle CED right here. We note that AB is parallel with CE, and C is the midpoint AD. Now, parallel lines, we should always immediately think, all right, what's our congruent angles? So let's mark those parallel lines. I'm going to mark them in blue. Just like that. Now, where is the transversal that intersects both of them? Well, we can certainly use this as our transversal. Now, on here, I can note, for instance, that like there's this angle here touches the parallel line and the transversal, the blue and the red line. The angle on the other triangle that does that would be this one here. They touch the parallel line and the red transversal. And notice how they're in the same positions as each other. So this is our hint that it's corresponding angles. So I'm going to say that angle BAC is congruent with angle ECD because they are corresponding angles. They're in the same position on the parallel lines. Then I note that, well, C is the midpoint. This C is the midpoint of AD, so it must cut the line into two equal pieces. So we can establish that AC is congruent with CD by the definition of midpoint. Finally, concluding that we have our angle, other pair of angles, and then we have our pair of sides. So therefore, by angle, side congruence, the two triangles are the same. And that is it for angle, side for now.